Okay, let's now look at question 9, which is probability. So it says, on a flight, passengers could choose between a vegetarian snack and a chicken snack. The snacks selected by the passengers were recorded, and the results are shown in the table below. Okay, so we have a table. We have the snack that they chose and whether they were male or female. Okay. Was the choice of snack on this flight independent of gender? Motivate your answer with necessary calculations. Okay, so how do we know if two events are independent? So let's say I have two events A and B. A and B, right? Now if the two events are independent of each other, the probability of A times the probability of B is equal to the probability of A and B. Okay? And if they're not independent, then they won't be equal. Okay, so let's see now whether your gender, whether the snack was dependent on gender. Okay, so let's choose an example, right? Let's choose our events A and B. So let's make event A being vegetarian. So you chose the vegetarian snack, and let's make event B being male. Okay. So the probability of being male, was 67 over 150, right? That's the probability of being male. Okay, so 67 over 150, right? The probability of taking a vegetarian snack was 32 over 150. Okay, 32 over 150. Now the product of those two, so the probability of being male times the probability of taking a vegetarian snack was 67 over 150 times 32 over 150. Okay, now let's just simplify that. So 67 over 150, I'm just using my calculator to get the answer, times 32 over 150. That gives us 0.095. Okay, 0.095. And the probability of male and taking a vegetarian snack was 12, right? Because these people were both male and took vegetarian snacks, so it's 12 over 150, right? And 12 over 150 is the same as 0.08. Okay, so you can see that the probability of male times the probability of taking a vegetarian snack is not equal to the probability of being male and taking a vegetarian snack. Okay, so therefore the events are not independent. Okay, cool. So make sure you actually state that conclusion, because there's marks for stating that, and make sure that you say that they aren't equal. Okay, cool. Let's look at 9.2 now. 9.2 says, for any two events A and B, it is given that PA and B equals to what? 0.12, and PAOB equals to 0.83, and PB, okay, PB equals to 4 times PA. Are the events A and B mutually exclusive? Okay, what does it mean to be mutually exclusive? It means that if you pick A, you can't pick B. Okay, and if you pick B, you can't pick A. Okay, so an example of this would be choosing between maths and maths lit in school, right? If you do maths, you can't do maths lit, right? And if you choose maths lit, you can't take maths. Okay, so that's a mutually exclusive event. You're picking one over the other. So that means the probability of A and B should be 0, right? Can you get anyone doing maths and maths lit? No, you can't, right? So let's look at this question now. The PA and B equals to 0.12. So therefore these events are not mutually exclusive, because PA and B is not equal to 0. Okay. 9.2.2, calculate the probability of B. Now here we're going to use that this rule here, right? That the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay. So let's read the question again, and we're given most of this information, right? So A or B was 0.83, right? There's it there. The probability of A is, well, it's an unknown. Let's just leave it as PA. The probability of B is 4 times PA. Okay, 4 times PA. And PA and B is 0.12. Okay, so let's solve for PA here. So I'll just bring 0.12 to that side, and then we can divide by 5, because when I add this together, I'm going to get 5. Okay, so 0.83 plus 0.12 divided by 5. And that gives us a probability of A equaling to 0.19. Right? And we know that, and we are asked to solve for PB. But we know that PB is just 4 times PA. Okay, so therefore it's 4 times 0.19. And that's equal to 0.76. Okay. The next one says calculate the probability of not A. Okay, so that's simple. Think about it. The only way to be not A is if you anything but A, right? So the probability of not A is just 1 minus the probability of A. So it's 1 minus 0.19, which was 0.19, 0.81. Okay, so that's that.